Okay, this is a video to review finding all the factors and zeros of a polynomial and also to apply the fundamental theorem of algebra. The first thing I want you to do is pause the video and just real quick, if you need to, write down the definitions of these different number groups and also to work on this warm-up. So please pause the video now. Okay, so hopefully the first thing you did was that you applied the rational root theorem for the warm-up. Board went off. And you looked at the constant, which was 15, and you took factors of the constant, which would be 1, 3, 5, and 15. And you put that over factors of the leading coefficient, which was just 1, so it would be plus or minus 1. So your possible rational zeros would be 1, negative 1, 3, negative 3, 5, negative 5, 15, and negative 15. And we're going to start by dividing these rational zeros in using synthetic division. So we've got 1, negative 2, 2, negative 1, negative 10, and a negative 15. So if we drop down the first one, multiply across, bring down, multiply across, add down, multiply across, and it's looking like it's not going to be 1. No, that would not be 0. So let's try negative 1. If we take negative 1 goes in, 1, negative 2, 2, negative 10, negative 15. So let's see, we've got 1, negative 1, negative 3, 3, 5, negative 5, negative 15, positive 15, 0. So that means that negative 1 is going to be our first 0. So now we need to find the other zeros. So we know right now from this that our polynomial will factor to x plus 1, because it's x minus k, times, now we've got these coefficients, 1, negative 3, 5, and negative 15. Well, if you kind of look at it this way, this is the remainder, this must be the constant, this must be x, x squared, and x cubed. Oop, that's a 3. The other way, of course, to look at it is that this is the x to the 4th, divided by x, this must be drop the power x squared. So now I'm left with 4 terms, and let's look. Do they group? If I take out x squared, I'm left with x minus 3. If I take out a 5, I'm also left with x minus 3. So I've got x plus 1 times x squared plus 5 times x minus 3. And that means that my zeros will be negative 1 plus and minus I root 5 and 3. And those are all the zeros. Here are the answers to last night's homework. If you have any questions, you can refer to the note sheet that was given out in class that has 2 problems on it. Or you can come see me tomorrow at lunch. Alright, today we're going to talk about the fundamental theorem of algebra. Please write this down. The fundamental theorem of algebra states that the degree of a polynomial function will equal the number of zeros it will have, and this includes complex zeros and repeated zeros. Pause the video and write that down. Okay, so if you think about our warm-up problem, we had something that was 4th degree. The highest power was 4. And if we look at our zeros, we had 1, 2, 3, 4 zeros total. 2 of them were real. 2 of them were imaginary. Now we want to remember that our imaginary zeros will always come in pairs. Now a repeated zero would mean, like, let's say you had factors like x plus 1 times x plus 1, that would be a repeating zero because negative 1 appeared in 2 different factors. You are going to find that today's lesson is not going to be a whole lot different than previous day's lesson. So let's take a look. Make that a little bigger. Factor and find all the zeros of this 5-term polynomial. Well, it's got 5 terms, which means we cannot factor it, which means we've got to start off with the rational root theorem once again. So factors of the constant over factors of the leading coefficient. Boy, I hope something nice works. We've got 1, -1, 3, -3, 9, -9. Let's start with our friend 1. And we've got 1, -2, 10, -18, and 9. So drop the first one, multiply across, add down, multiply across, add down, multiply across, add down. Sweet! First one worked. So we now know that x minus 1 is our first factor. And our second factor will be x to the third minus 1x squared plus 9x minus 9. And looking at this, I can already tell that this is going to group. We've got x squared times x minus 1 plus 9 times x minus 1 is going to give us, hey, look, a repeat. The factor of x minus 1 has appeared twice. That means it's a repeating 0. So our zeros here, I'm going to write it twice because I want to be clear that I found it twice, are going to be 1, 1, and then if I solve x squared plus 9 equals 0, obviously I would get x squared equals -9, which gives me plus and minus 3i. Okay. Example 2. Same situation. We are going to factor and find all the zeros of this polynomial, which looks a little scary because I don't see any coefficients except -1s and a -2 for the constant. So again, we're going to start with the rational root theorem, and this time it's not going to be so bad because it's just plus minus 1 and 2 over 1. So my possibilities are 1, -1, 2, and -2. So let's try 1. We've got 1, -1, -1. How many are there? 1, 2, 3. I'm not missing any powers, and -2. Here we go. 1, 1, 0, 0, -1, -1, -2, -2. That's -4. So 1 doesn't work. Let's try -1. We've got 1. That's not a straight line. So we've got 1, -1, -2, 2, 1, -1, -2, 2, 0. Woo, -1 works. And I can already see when I'm looking at these coefficients that they are going to group. And my first factor will be x plus 1. And my second factor will be x to the third minus 2x squared plus x minus 2. And I'm going to group that. So my factors are x plus 1, x squared plus 1, and x minus 2. So I have two real zeros, which are -1 and 2. Then I have two imaginary zeros, plus or minus I. Okay, the last thing we're going to do today is we are going to talk about how to write a polynomial function when we are given zeros. So here we go. It says write a polynomial function f of least degree that has real coefficients, a leading coefficient of 1, and zeros of -1, 5, and 6. So the first thing I'm going to do is I'm going to write f of x equals 1 because my leading coefficient is 1. If I have a zero of -1, that means I've got a factor of +1. If I've got a 0 of 5, that means I've got a factor of x minus 5. And if I've got a 0 of 6, I've got a factor of x minus 6. So I'm in pretty good shape. I have my polynomial in factored form. We really want to put these into standard form. So what we're going to do is very carefully multiply these three binomials together. What you do not want to do is try to distribute the x plus 1 to each. We're going to take 2 at a time. Because remember, if you had 2 times 3 times 4, you would do 2 times 3 is 6, and then 6 times 4. You wouldn't do 2 times 3 and then 2 times 4. That would be like some crazy arithmetic. That's a terrible eraser. Alright, so here we go. X plus 1 times x minus 5 is going to give us x squared minus 5x plus 1x minus 5, which will give us x squared minus 4x minus 5. We need to multiply that times x minus 6. So first I want to multiply everything by x. X to the third minus 4x squared minus 5x, and then everything times negative 6. And when I do that, I'm going to kind of line everything up nicely. So when I do negative 6 times x squared and get negative 6x squared, I like to do my multiplication like this. That way my like terms are all together. And then negative 6 times negative 4 is 24x. And negative 6 times negative 5 will give me 30. So f of x, then it's kind of like a big addition problem. F of x is x cubed minus 10x squared plus 19x plus 30. Okay, I want you to take a minute and you try the next one. Just try number 9. Write a polynomial function of least degree that has real coefficients, the given zeros, and a leading coefficient of 1. Okay, so for number 9, I don't know why that little 4 is there, but that's okay. For number 9, what you should start off by doing is saying f of x equals 1 times x minus 2 times x plus 1 times x minus 5. Because again, if k is a 0, x minus k is a factor. Then what you need to do is multiply together x minus 2 times x plus 1. And when you do that, you're going to get x squared there it is. X squared minus x minus 2. And we're going to multiply that times x minus 5. So first I'm going to distribute the x, again, just like we did before, and we're going to get x to the third minus x squared minus 2x. Then I'm going to distribute minus 5, and I'm going to kind of line everything up again. And then my final answer for number 9 is going to be f of x equals x cubed minus 6x squared plus 3x plus 10. Okay. The last one we're going to do before you can start your homework is going to be number 10, which is to write a polynomial function that has zeros of 3 and 2i. Now, if you think about it, the only way I can get a 0 of 2i is to be in the situation where I had x squared equals negative 4. Because then I would take the square root of both sides and get x equals plus or minus 2i. So if 2i is a 0, negative 2i has to be a 0 also. So when you get a 0 when you get a 0 that's a pure imaginary like this, you immediately include the conjugate. Always, always, always. So if 2i is a 0, so is negative 2i. And you can kind of guess that the factor that 2i came from would be x squared plus 4. And then the factor that 3 came from would be x minus 3. And if we multiply this together, there's our polynomial. Again, let's say I had, just as another example, let's say we had 5i as a 0. Well, the only way we could have 5i is if we had x squared equals negative 25. And that would mean that negative 5i is also a 0, and that would mean that x squared plus 25 is our factor. Right now, I want you to go ahead and start the homework, which is, there's a worksheet in your packet that says Daily Homework Quiz 6.7. Numbers 1 to 4, and also there's a little bit of bookwork. When I turn the page for the video, it will show the answers, so go ahead and get started and don't look up if you don't want to see the answers. Oh, those are stuck together.